Okay, guys, another rate in, rate out problem for today. I'm going to demonstrate one. It has some similarities to the one we did on Monday, but it has something new. Part D is kind of new. You'll notice that all of these have slight, subtle differences. So even the one that you do for homework will be just subtly different than this. Pay attention to those subtleties and especially watch the solution videos, especially for ones that are unique. All right, a lot of this will be done on the calculator, so there'll be a companion calculator video that goes with this. But let's look at what this question says. The rate at which rainwater flows into a drain pipe, so into, that's this rate. I'm going to tell you guys that I'm going to put that in as Y1. Remember, we're in radian mode. We're always going to be in radian mode. That's in cubic feet per hour, so I notice the units, and it goes from hour 0 to hour 8. The pipe is partially blocked, allowing water to drain. So we have a drain model right here. And I'm going to actually put that in for Y2 into my calculator from 0 to 8. And then they give us this nice, there are 30 cubic feet of water at time equals 0. Okay, so for part A says how many cubic feet of water flow into the pipe? Into the pipe was this blue function. So that'll simply be the integral, and it says over the first 8 hours. So it'll be the integral from 0 to 8 of r of t dt. You can actually write this, since they've assigned that a name to that function, you can actually write it as r of t dt. You may also write the whole thing out if you want, the integral from 0 to 8 of 20 times the sine of t squared over 35. I don't know that that's necessary if they've labeled that for you. And then for the second part, what they want to know is what does that equal? And when we plug that into our calculator, we end up getting 76 point, remember 3 decimal places, 570. It doesn't ask for units because it asks in the question how many cubic feet. If they had asked for units, we would put cubic feet. They didn't ask for units. So that's part A. Okay, now let's read part B. Is the amount of water in the pipe increasing or decreasing at time equals 3? So the reason I highlight that is sometimes, guys, they're going to ask, is the rate of change increasing or decreasing? We're going to look at an example of that later this week or maybe into next week. Rate of change, increasing or decreasing, is rate of change, right? So that would be acceleration. But for this particular example, they're asking if the amount is increasing or decreasing. So here you've got the amount, you've got the two functions they give us, r of t and d of t, and then you have, right, that's the derivative of the amount is the rate at which it's changing, and then the derivative would kind of almost be like acceleration of how it's changing, the rate of change of the rate of change. Since they're asking us about this, how the amount is changing, we're just going to compare r of 3 with d of 3. So if you've already got this in your calculator, if you've already got y1 and y2 input, you can literally, I'll show you on the calculator, you just do y1 of 3, and we would get 5.08636 on and on. And for d of 3, we would get 5.4. So what we could say then is, since d of 3 is greater than r of 3, think about what that means. There's more draining than there is coming in, there's more flowing out than there is flowing in. We would say the amount of water in the drain be specific on the time, at the time t equals 3 is decreasing. It's decreasing because there's more draining than there is flowing in. You have to answer the question the way that they phrase it. If they want to know the amount of water increasing or decreasing, you have to use one of those two terms. You can't say, oh, there's less water in there. Okay, they're not going to accept that answer. You have to do that. And where it says give a reason for your answer, they're going to look here. So you can't just say D3 is bigger than R3. You have to actually show the values for which they are. Okay, guys, we look at part C. It says, at what time is the amount of water a minimum? So this is kind of like part D of the example we did Monday, the one that I said was kind of tough. For part C, well, what is the total amount of water? Well, the total amount of water is going to be 30, what we originally started with, plus the integral from 0 to t of r of x dx, minus the integral from 0 to t of d of x dx. Now you might say, well, Mr. Ashby, why are you using x's here? Here's the thing: you can't use the same variable here that you do up here. So these are called down here. These are kind of called dummy variables. We kind of just plug something in so that when we would look at our function, and in fact, probably a better way of writing this would say a of t. So now if we were to plug a value in for time, that would go where we see our two time intervals, and we would be able to calculate that. So you put some dummy variables in there if you need to. Now, where does a minimum occur? Well, a minimum occurs, if this is the time and this is the amount of water, a minimum can occur at the two endpoints, so at 0 or 8, or anywhere where the derivative equals 0, we have a critical number, okay? Critical numbers, maxes and mins occur at critical numbers. So what I'm trying to find then is the derivative of this. Well, the derivative of 30 is 0. The derivative of that, well, the derivative of an integral, this is the second fundamental theorem, is just going to be r of t minus the derivative of from 0 to t of d of x is going to be d of t. And so, of course, I want to see where that equals 0. Where that equals 0 is a critical number. This I have to do in my calculator. So consult the calculator video. Basically what I'm going to do is I'm going to create a third line, y3, where I do y1 minus y2. That'll be the only one I graph, and I'll see where it crosses the x-axis at 0, between 0 and 8. Okay, guys, so I did that in my calculator. Again, consult the calculator video, but I found that it crosses from below the x-axis to above. It crosses the x-axis at 3.2717, let's say. And so that's great. So that's part of what they want. They want us to find that time interval, but that's only worth one of the points. So what I have to do is I've got to fill out this chart here. I've got to find the actual amount. Now, lucky for us, I drew up an amount function. So I'm literally going to do a of 0, a of 3.2717, and a of 8. Now, this one in the middle, I want to have saved that number. I will have stored that number in my calculator so that I end up getting an exact number, the one that's not rounded. But a of 0 is just saying, well, what was the amount at 0 when we started? We don't really need to do a lot of calculations. They told us there was 30 cubic feet when we started. But the other two I'll have to use in my calculator. And so if you consult the calculator video, I'll show you how I did that. But what I would have there is I would have 27.965. 27.965 for this one, and 48.544. So 48.544 for that one. So my final answer, the final thing that I say, is I would say, it asks me, at what time is the amount of water in the pipe a minimum? And I would write the water in the pipe is a minimum at t equals 3.272 seconds, and that would be my answer. I'm sorry, it's not seconds, it's hours. Let me take that back. Pay attention to the units there. I almost messed that up. Hours is the units, not seconds. If you put seconds, you actually wouldn't have gotten credit for that. So make sure you pay attention to units. I almost made that mistake there. All right, last one here, guys. This is one that's a little different. It's actually pretty easy here. it gives us some extra information. The pipe can hold 50 cubic feet of water before overflowing. For all times greater than 8, which is where our interval stopped, water continues to flow in and out at the given rates. Okay. Write but do not solve. If you ever get one that says write but do not solve, don't make life harder on yourself. We're simply setting up an equation. We do not have to put it in our calculator and solve. So write but do not solve an equation involving one or more integrals that gives the time W when the pipe will begin to overflow. Well, let's think about this. The pipe overflows when it's greater than 50, but when since it's continuing to go up, I want to see when it equals 50 exactly, because that's where it would cross that line. So 50 had have to equal the amount. Well, we already know the amount, don't we? We already know the amount. They told us that. The only thing that they changed in here is that they said, hey, we want you to call that specific time W. So we could say 30 plus the integral from 0 to W of R of t dt minus the integral from 0 to W of d of t dt. Now, what's interesting about this function as well is that since that's our answer, we could be done, that's it, you don't have to do anything else, you don't have to subtract 30 from both sides, you don't do anything with that. But an alternative answer, just to show you, especially if you're looking at some of these answer keys, if you notice the limits on this integral and the limits on that integral are the same, and since those limits are exactly the same, again, you can only do this if those limits are the same. I think you guys did an example with bananas in a supermarket, and those limits were different. If the limits are ever the same, though, you could write it to where they're under the same integrand. So you could go 30 plus the integral from 0 to W of R of t minus d of t. Make sure you put these parentheses or brackets there before you put dt. And so now, when we look at this, this is an alternative answer that is also correct. Either one of these would be correct. Hope that helps, guys. Good luck tonight. Solution will be posted tomorrow. We'll do one more example tomorrow, and then on Monday there'll be a quiz over only a rate in, rate out problem. So it'll be a little bit smaller than the last one you took.